Again, welcome to Mathematics 164 Precalculus. This is our lecture 6-1, which cover chapter 6, section 1 of our course textbook. In these lectures, we're going to learn how to find the simple interest and also the sequences. So our main object is to learn how to find the future value and the amount of interest for a simple interest loan and an investment. Also to find the simple interest rate and on an investment. Also to find the time required for a simple interest investment to reach a goal. We're also going to learn how to write a specified number of terms of a sequence and also how to find the arithmetic sequence. So we start with a simple interest. And here we said if a sum of money P, which we call the principal, is invested for a time period T, which is normally will be in years, at an interest rate R per period, then the simple interest is given by the following formula. And the simple interest represent I is given by I equal to PRT. Again, P is the principal amount, the amount we want to invest in dollars. R will be the annual interest rate, and normally we write it in decimal. Then the time will be in years period. So let's try one example here. For example, we have 8,000 is invested for 2 years at an annual interest rate of 9%. How much interest will be received at the end of 2-year period? So all the three items are given to us. We know the principal amount to be that was invested, $8,000. We know the time period for the investment is 2 years. And also we know the rate or the interest rate, annual interest rate, which is again 9%. So in this case, we can find the interest after 2 years or the end of 2-year period. So the interest here will be the principal times the rate and times the time, which will be 8,000 times, since the time is in years already, we don't need to change it. So it will be 8,000 times 2. Then we change the 9% to 0.09. And the answer will be the interest we get at the end of 2 years. So let's see the calculation here. The interest rate will be I equal to PRT. Again, P is the amount invested, which is 8,000. The rate is 9%. We change it to decimal 0.09. The time is in years already, so it's 2. The interest rate is also is yearly, annual interest rate, and the period also has to be yearly. So when we multiply the three items, we get 1,440. So that would be the interest paid after 2 years. Now let's see the second question. Here we said that if 4,000 is borrowed for 39 weeks at annual interest rate of 15%, how much interest is due at the end of the 39 weeks? Now, as we said, the time period will be in years. So since this is 39 weeks, we have to convert it to years. So for example, if we have 52 weeks in a year, then 39 divided by 52 is the year. Or if it's 53, 55, whatever weeks we have per year. So we need to convert the weeks to years. So that's our B. Again, the interest is the same formula, I equal to PRT. But this time, the time is given in weeks. So we convert to yearly first. So T equal to 39 divided by 52, which will give us 0.75 year. Now we can plug in the value. So we have 4,000 investment, 15% interest becomes 0.15. We change it to decimal. Again, if you have any amount in percent, you divide by 100, you change the value to decimal. So 15% is 15 divided by 100, which will give us 0.015. Then the time period, we convert it to yearly instead of weeks. So 39 weeks divided by 52 gives us 0.75 year. So after the calculation, we get $450 for the interest. So we also have the idea of a future value, how to find a future value. So the idea is that, which was the previous example we did. For example, we have $8,000. We invested it for 2 years and our interest was $1,440, which was our first example. Now, if a question is given and they say, what would be the amount of investment or its future value, the future amount of an investment or its future value, then it will be the actual amount plus the interest that will be earned. So in this case, we have $8,000 after 2 years, we have interest of $1,440. The interest was 9%. So the future amount of an investment will be 8,000 plus 1,440. And that's what we said, the future amount of an investment or its future value at the end of an interest period is the sum of the principal and also the interest. So in example 1A, the future value will be the 8,000, which is our original principal, the amount we invested, plus the interest we are going to earn, which is 1,440 after 2 years. Similarly, the second example, we invested 4,000. When we find the interest, we get 450. So the future amount of the loan will be 4,000 plus 450, which will give us 4,450 or 4,450. So the future value formula will be, and we represent future value as X, and it's equal to P, which is the principal amount, plus I, which is the interest. So here we say the principal P of an investment is also called the present value of the investment. So the future value of the investment or loan is always the present value of the investment plus the interest that will be earned at the end of the period. So the present value of a loan is the original loan amount, which is also called as the face value of the loan. So we have an example here. If 2,000 is borrowed for 1.5 years at a simple interest rate of 12% per year, what is the future value of the loan at the end of the half year? So first we need to find the interest. When we get the value of the interest, we add it to the principal and that will give us our future value. So let's see the calculation. First, the interest for the half year. Again, we have to change the period to yearly. So half year means 0.5 year. The amount of investment is 2,000. The interest rate is 12%, so it will be 0.15. And for a period of half year, so it will be 0.5. That gave us 120. So the future value of the investment will be 2,000 plus 120, which is P plus I. And that will give us 2,000 plus 120. So our future value of the investment after 6 months, it will give us $2,120. Now the B question, let's go back and see the B. B said an investor wants to have $20,000 in 9 months. Now, if the best available interest rate is 0.05% per year, how much must be invested now to yield the desired amount? So this means we have an investor want to have 20,000 in 9 months. So the future value is given to us. The future value after 9 months or in 9 months will be 20,000. And also, if the best available interest rate is 6.05 per year, how much must be invested? So we can find this by first of all writing the formula for future amount is given. So it will be S equal to P plus I. But in order to find I will give us what? The P times R times T. So we have the S value 20,000 given, which is equal to P. That's what we are looking for, the principal amount. This is in 9 months, the amount will be 20,000. So that means our time period will be, in yearly, it will be 9 divided by 12, We know the interest rate is 6.05, so it will be 0.0605. Interest rate always must be changed to decimal. Yearly, always for the time. We are looking for P, so we don't know P. So here we can do the calculation, 0.0605 times 9 divided by 12. The answer we get, we have P and P, so it's a like term. We had this will be 1P, and whatever answer we have here, we had it together, then we do our calculation. So here we get P plus, again, the P here plus 0.045375P. After we multiply 0.0605 times 9 divided by 12, we get 0.045375P. Then we add it to P, so that will give us 1.045375P equal to 20,000. And that's what we have here. Now, since 1.045375 is multiplied by P, when you cross the equal sign, it's going to divide. So our final answer will be P equal to 20,000 divided by 1.045375. And our final answer will give us, we need to invest $19,131.89 at interest rate of 6.05. In 9 months' time, we will get the $20,000. So let's move to sequences now. The whole idea of a sequence, we said if a function whose domain is the set of positive integers called a sequence function. A function whose domain is a set of positive integers is called a sequence function. Then the set of function output of a sequence function will look something like this. F at 1 will give us A1, F at 2 equal to A2, all the way to F at n equal to AN. This will form an ordered list called a sequence. So the output will be A1, A2, A3, etc. Now to find A1, F at 1, value equal to A1, then F at 2, A2, F at n, AN. So we get a sequence. The difference between A1 and A2 is the same as A2 and A3. So let's see an example how this works. So here, for example, they say we should write the first 4 terms of a sequence whose nth term is an equal to -1 to the power n divided by 2n. So this means if I'm looking for, we are going to write the first 4 terms. So if I'm looking for A1, anywhere I see n, I'm going to substitute it with 1. So we get something like this. A1 will give me -1 to the power 1, 2 times 1, because 2 times n is 1. So -1 to the power 1 will give us 1, 2 times 1 will also give us 1 with a negative sign. Now, if I'm looking for A2, it will be -1 to the power 2 divided by 2 times 2, because n, -1 raised to the power n, so n is 2. To be -1 to the power 2 divided by 2 times n is 2, so it will be 2 times 2. And we know that if we have a negative value and the exponent of the negative value is an even number, then the answer will be positive. So -1 squared will give me +1. Then 2 times 2 is 4. Same thing, we can look for the third term, -1 to the power 3, 2 times 3. So since 3 is a odd number, our answer will be negative. So we get 1/6. 2 times 3 is 6. Then 4, again, 4 is even number. So -1 to the power 4 will give me +1. Then 2 times 4 will give me 8. So that will be our solution. Again, the question said we should write the first 4 terms of the sequence, whose nth term is given as this. So A1 will substitute 1 with the n, A2 will substitute 2 for n up to 3, 4. So that's our sequence now, -1/2, 1/4, -6, 1/8. Now let's go to the concept of arithmetic sequences. So here we say we have a sequences 2020, 2040, 2060, 2080, 2100. This can also be described in the following way. If A1 is 2020, then AN equal to AN minus 1 plus 20, which means the previous value, I'm going to add 20 to it to get a present value. And we can see if I have 2020, I will add 20 to get 2040. If I'm at 2040, I will add 20 to it, then I'll get 2060. If I'm at 2060, I will add 20 to it, I will get 2080. If I'm at 2080, I will add 20 to it, I will get 2100. So that's why we say AN will give me N minus 1, the previous value, plus 20, then it will give me the present value. Here, the rule will say that N should be greater than 1. These values have to be positive values. So this sequence is an example of a special kind of sequence we call the arithmetic sequence. So in such sequence, each term after the first term can be found by adding a constant to the preceding term. So that's why we call this sequence arithmetic. Normally, we are going to represent the constant value as D, or some textbook may use any other symbol. So in this case, our D or C will be 20 because that's what we are adding to the next values. So that's the official definition of arithmetic sequence. So a sequence is called an arithmetic sequence, which is in progression if there exists a number D called a common difference such that AN equal to AN minus 1 plus D. So D will be our example, D is 20. We had 20 to previous value, we get a new value. We had 20 to previous value, we get another new value. In this case, N should be positive value and not 0 also. And it should be greater than 1 because if it's 1, I mean, you go only once. N is the number of terms we are going to have in the sequence. So the formula for the nth term of arithmetic sequence is as follows. If I'm looking for nth term of arithmetic sequence, that's what we said. AN will be A1 plus N minus 1D. So the first value plus N minus 1, because 1 value then times D. The reason why, because we are going to add D to each value. So if I have 4 values, I'm going to add D 3 times because I have my previous value. So instead of adding 3 times, what I will do, I'll just multiply the number of three values with the D and add it to the first value to give me any position. So we can use this formula to find any position of a value if we know the beginning value and we know how many terms, then the D. So we'll see one example right now. Also, we can find the sum of an arithmetic sequence. Again, here we are looking for the term AN. N can be any position. Say A2 means the second item, A100 means the 100th item. Then first we know the first item. If it's 100, then we have 99 items that we have to add 10 to. Since we don't have the value, we just multiply 99 by D, the constant value, which is 99 times we had. So multiply. Then we add it to the original first value. Now here we want to find the sum of all the elements in the sequence. So Sn, again, N is how many items we have in the sequence. It will be N divided by 2. Then the first item adding to the second item. And the last item. So if I have 2, 4, 6, 8, and I want to find the sum of it, I can say 2 plus 4 plus 6 plus 8 is the same answer I will get if I say 4 divided by 2 times 2 plus 8. The first term is 2, the last term is 8, and I have 4 elements, so it will be 4 divided by 2. And that will give me the sum. Again, if it's only 4 items, it's easy. I can just add it. But imagine if we have 100 items. We don't want to waste time counting 1 plus 2 plus 3 plus 4 up to 100. So let me take the first term 1, the last term 100. So 1 plus 100 times 100 divided by 2. That will give me the sum of from 1 to 100. So let's see some few examples here. Here they say we should find the sum of the first 10 terms of an arithmetic sequence with first term 2 and the common difference d. So if we know the first term and also we know the common difference, then we can be able to find any term position. Here we want to find the first 10 terms. So the formula will be, we are giving the value n will be equal to 10 since we are finding 10 terms. A1, the first item is given to us is 2, and the common difference we are going to add is 4. So we put for the first formula, A10 will equal to the first item, which is 2 plus n minus 1 times the d. So we get A10 will be 2 plus 10 minus 1 times 4. Why 4? Because the formula is times d. Why 10? Because n is equal to 10. And the first item, A1 plus n minus 1 times d. So A1 is 2, n is 10, minus 1, then d is 4. And the answer will give us 38. Now the second question said, find the first 91 terms of the arithmetic sequences. So if we are looking for the first 91 terms of arithmetic sequences, we know 1, 4, 7, 11, 11, 12. Then we have to find the first 91st terms. But first, let's finish with this. So we find the sum. The sum, again, this is the 8th item will be 38. Now to find the sum of the first 10, as we said earlier, again, to be n divided by 2, which is 10 divided by 2. Now we know the last item, which is 38, because we are finding the sum of the first 10. So the sum formula is what? Add the first element plus the last element. This time the sum 10. So the last element is 38. Then times the number of elements, 10 divided by 2. So that will give us 200. Now let's look at the second question. The first 91 terms of arithmetic sequence, this is given to us. So the first thing we're going to do, since we know the first term is 1/4, and also we will test it. Let's subtract 7/12 from 1/4 and 11/12 from 7/12. If the answer is the same, then we have the d. And that's what we did here. The first term is 1/4. The common difference was 1/3, because if I subtract the first term from the second term, I'll get 1/3. If I subtract the second term from the third term, I'll still get 1/3. As we see here, this is 7/12 minus 1/4 will give you 1/3. 11/12 minus 7/12 will give us again the same value. So if that is the case, we know the d. Therefore, then the 91st term is, we are using the previous formula again, A91 equal to 1/4 plus 91 minus 1. The reason why it's 91, again, 91 is n, because 91 item. And why 1/4? Because our first item in the SIG, they give us the first 3 items. The first item is 1/4. The 91 minus 1, 1/3. So this will give us the last item. By calculation, we get 31/4. Now we can be able to find the sum, same as our previous example. So sum 91 will be n divided by 2, which is 91 divided by 2, times the first element will be 1/4 plus the last element, which is 121 by 4. And this will give us, our final answer will be, after cancel everything, we get 1,387.34. So that will be the conclusion of this lecture. Again, this lecture covers our textbook, chapter 6, section 1. And the main goal is to learn how to find simple interest, and also how to find sequences and also arithmetic sequences. Again, if you have any question, post it in the Blackboard, or you can send an email. And again, wish everybody the best. Thank you.